Talk about exponents. Exponents are important because we use a lot of them for scientific notations, and also we can tell the orders of magnitudes. Okay, and we'll come back to that a little bit. The exponent simply is multiplying how many times that's on the top number of the base numbers. So 5 to the 3 will be multiplying 5 3 times. But if you have a negative exponent, for example, a to the minus x, 5 to the minus 3, then that will be you are inverting minus and multiplying it 3 times. So we'll be inverting 5, 1 over 5, and multiplying it 3 times of that number. So 2 to the minus 4 will be 1 over 2 to the 4. That's what the negative exponent means. And then we also have the fractional exponent. So if you have a square root of 2, if I want to write that in exponent, it'll be 2 to the power of 1 over 2. 3 to the root of 8, then that will be 8 to the power of 1 over 3. Base number to the 1 over n will be the root of the n of a. Okay, so remember that. And so if you have m over n times, then you're going to be doing the root, because the 1 over part, the root of m, the base a, and then we'll be multiplying m times, okay, of that root. And of course, always, the base to the 0 is always 1. 5 to the 0 is 1. 2 to the 0 is 1. Let's look at some examples. Like I said, exponents are used for the scientific notation, so which all of your answers in chemistry or physics or any science classes will be in scientific notation. So you have to get used to using the base of 10, right? So if you have 10,000, count the zeros, and if it has 4 zeros, it's to the power of 4. Tells you the order of magnitude. Okay? So if that exponent number is bigger, the order of magnitude is bigger by that much number. So if I compare 10 and 10,000, to compare 1 to the 4, then this is bigger by 3. It is 3 orders of magnitude larger. And 3 orders of magnitude is 10 to the 3, 1,000. That's how we determine the order of magnitude, and it comes in very handy when we're just going to estimate answers using order of magnitudes. All right, back to the exponent point. 10 to the factors are on the left side. If you have a smaller than 1, just fractions, then it'll have a negative exponent, and it's easy to track the decimal points. So if I do this one here, decimal is right here. So you will move the decimal to make it 1. So it's 1 times something. So then this decimal goes 10, 100, 1,000, and 10,000. So that means 1 order of magnitude, 2, 3, 4 orders of magnitude. So it'll be 1 times 10 to the 4 orders of magnitude, but it's smaller than 1. It's a fraction, therefore minus. Don't forget that. And practice it with the real numbers on the right side also. You will have a pretend decimal there. Even though you don't see it, it's always there. Move it to the 2.4. So go by 1 order, 2, 3, 4. Then it'll be 2.4327 times 4 up there. And I just wanted to note here that when you use your calculators, you are going to see this letter E, or sometimes it's written like 2.5 with a big E and a 5 there. Okay, that's all telling you it's an exponent, not a some number E, not a variable E. Okay, it's just telling you that your answer is 2.5 times 10 to the 5. That's what that E is telling you in your calculators. Don't forget it, right? How do you use your exponents? If your base is the same, when I multiply it, I can add the top exponent together. 10 to the 3 times 10 to the 2 is 10, because I multiplied it. 10 to the 3 times 10 to the 2 is 10 to the 5, 3 plus 2 on the top. If I divide it, because I'm inversing, you become a minus there. But if I do a 2 exponents, they get multiplied, okay? Make sure you can tell the difference. If you are multiplying the entire two exponents together, you can add it. But if you are doing an exponent to the exponent, you have to multiply that. Big difference. But review yourself that that is the true case. And if you have an exponent to the 2 multiplication, you can expand it to the a and the b separately. Same for the inverse. To the power of 0 is always 1. Inverse we did already. And then we have the fractional exponent, where the inverse exponent is the root of that number. Now we do some examples. All right, pause me. So here, because I have an exponent to the exponent, we're going to apply that to both numbers. You can, or I can do the inside first and then do the exponent. I'm going to do the inside first, okay? 10 to the power of, because they're multiplied, it's 6 plus 4, but don't forget, we still have the minus 2 at the end. So let's do the 6 plus 4 on the inside, 10 to the 10. And we have to do minus 2. Therefore, 10 to the minus 20, because that gets multiplied. So now the z, let's do this one. Do it on your calculators. But how do you put it in your calculator? We're going to put up parentheses 2 times 10 to the 5 power of 1 over half, right? Square root. Now let me share the calculator. You can go square root, right? Or you can just push the square root button, honestly, for this one, okay? But if it was a 3 or something else, then you'll have to do that. So you can do 2 times like this in the square root. But I want to show you how to do the other way. So we're going to do 2 times 10 to the power, okay? So that, look at that bracket right there after the 10, 5, okay, bracket closed. And then we're going to raise to the power again for that over 1 over 2, right? So I need to do a parentheses 1 over 2 to do that, okay? Now I'm going to push equal to get the whole answer. That's 447.2 equals 447.2, okay? Yes, I could have used this 1 over x button here when I was doing to the power of half, okay? So if you know how to use those, use those. Just make sure you're going to raise to the entire power is going to be the half, okay? Not just 1 and then dividing the whole thing by 2. We don't want that. And of course, if you're not getting the right answers, you have to come find me. Now, this is more of an equation, but let's okay. Let's try it together. So 5 over x to the power of square root half equals 8. To get rid of this half, I'm going to multiply it by 2. So I'm going to multiply this by 2, which means I also have to raise this by 2. Okay, so that means what I did is 5 over x to the power of 1 over half. I'm squaring it so I can multiply that, equals 8 squared, right? If you square one side, you'll have to make sure you square the other side to be fair, okay? That brings us to canceling 2 times half is 1. Therefore, 5 over x is left equals 8 squared. Let's divide each side by 8 squared. 5 over x divided by 8 squared equals 8 squared divided by 8 squared. So I'm going to have 5 divided by x and 8 squared equals 8 squared divided by 8 squared is going to be 1. Now I have to isolate the x. So let's multiply x on this side and multiply the x on the other side. That means 5 over 8 squared, because x divided by x is 1, that canceled, equals x on the other side. 1 times x is x. So if you calculate 5 over 8 squared, 5 over 8 power squared is going to equal 0.078. 0.078 is going to be our x. Now logs, let's go by the definition really fast. If n is a to the power of x, when I put the base is a, So I find the a base of the log of n, that whole number, right? N is a to the x. Log a of n is going to be that exponent x. But the most thing that we use a lot is base 10, right? Base is 10. Then we don't really put 10 there because it's used a lot. Okay, so if you don't see any base number, it just assumes it's 10. So if I take a log of this whole 10 to the x, then I'll get that exponent x of it. ln is now log of the when the base is the number e, the exponent e of that n, then it gives you the top the same x, okay? But this also used a lot, so log of that base e, we call it the natural log ln. Let's practice a little bit of that too. So if you see log x is 5, then what's x? Because if you don't see a base there, it means 10. That means the top part of that 10 base is 5. If 10 to the 5 is n, right, like we did a definition, then log n was 5, okay? Log x is 5. That means the x is 10 to the 5, okay? So it's 100,000. Find c. So here, I want to get rid of this minus to the other side. So I'm going to write log c equals minus 4.6. I don't see a base here, 10, right? So it's a 10. So that number c is going to be base of 10 to the power, that's the exponent, power of minus 4.6, okay? And let's do that in the calculator because I can't do that. You can leave it like that too, I think. But 10 to the power of minus 4.6. So that should be smaller than a 1 number, okay? 0 point. Well, there you go. Oh, you see that little e there? That's our name, 2.511, 2.5118 times that e is, what did I say? It's telling you the exponent, 10 to the minus 5. All right, now 89.1 is e to the x. Remember, if the base is e, we use natural log. Let's do ln 89.1 equals ln e to the x, okay? We did a natural log on both sides. ln e to the x is just x equals ln 89.1. So in the calculator, we can do ln, let's find ln. ln, oh, I have to write the number first, I guess. 89.1, do a natural log, 4.49. Okay, I can explain that differently too, I think. Let's try. Go by the definition. Log of base a, right, of that n equals x. That means, right, n is a to the power x. That's the definition of log, okay? So try to match it. That means, look, base a, the exponent is x. So the exponent is the base a's of that entire number, okay? So I can do this one. Exponent is log of a, which is e here, the base is e. So e, okay, of that entire number, 89.1. All right, therefore that equals log e is ln, so I can do ln 89.1. Same thing, okay? Just using the definition here. Okay, go down here. You have some videos that you can watch, and you also have this review sheet that has a lot more practice problems with the answers, so you can practice more, okay? All right.